Hello everybody and welcome. In this video we are going to go over all the Python syntax we need for 9618 Cambridge A-Level Computer Science curriculum. I had a look at both the 2021 up to 2023 syllabus and the 24 up to 25 syllabus and created a checklist. Obviously, of course, went over a bunch of past papers with my students and found the solutions. And based on all that, I created this checklist. But be careful because this checklist, I believe, is complete and I believe it has a bunch of stuff in it which we don't even need, but I just put it on just to be on the safe side. But I cannot really guarantee that it's complete. So if you think I missed something, I should cover something else, please let me know in the comments. Anyway, I went over this checklist, and in order to go through this checklist, I created a bunch of questions. I recommend that you be able to solve most of these questions without sneaking a peek at the answer and without using any resources. Once you're able to solve most of these questions, is a good idea to start practicing past papers. So one more note, this is just about syntax and we don't cover theory. We don't cover things like sorting algorithms, abstract data types, and stuff like that. And as I already mentioned, hopefully I didn't miss anything, but if I have missed something, let me know in the comments. So this video is designed for revision, and this video is designed for getting to know the topics in the first place, and it's also designed for revision, but it's not sufficient uh, in and of itself. You need to get a lot more practice than what we're doing in this video. Okay, with all that said, let's get started. So the first exercise, we're starting with the basics. The first exercise is get a number from the user between 10 and 100. We've got to use the input function for that. So first of all, we need a variable, and I'm going to name this variable number. And let's use the input function and type get a number between 110 and 100. And let's run it. I'm going to control S this to save and press F5 to run. Oh, look at that. Get a number between 1 and 100, and we're going to type 30. And nothing happens. So in order for something to happen, let's actually print number. Whatever the user types is going to go in this variable. Let's type 5, and it prints 5. Let's do that again. So 5, we can already see is out of range. But we're going to solve that later. Let's try again. Let's type some letters. It accepts letters too. It's also a problem. But we're going to solve that in a little bit. But anyway, we've done the first part. Cast the input received from the user to make sure it's an integer. So in order to do that, we're going to use the int function. I'm going to say number equals int number. Now we're going to be almost certain that it's a number which we get, an integer. If it's not an integer, we're going to get an error message. Let's see, 11. What happens when I press, when we put in a text? Error message. Okay, pretty good. Print an error message in case the user did not input a number and ask the user to try again. Okay, let's do it. In order to do this, we're going to, oh wait, 1 second. See, I used 2 lines to achieve what we have so far, but if I wanted to do it in only 1 line, we can go like this, int of input. Does it matter if you do it in 2 lines or 1 line? The answer is not really. Does not really matter. This is the exact same thing. Okay, some people like to do it in 1 line because it's more compact. Some people like to do it in 2 separate lines because the code is easier to read. It's up to you. Okay, we're going to print the error message and we're going to ask the user to repeat. So we're going to use, for that, we're going to use a while loop. I'm sure you remember from pseudocode that a while is a precondition loop. So we're going to put the condition in the front. In this case, I'm going to do while true, which means it's just going to go on forever. Then I'm going to keep repeating this line over and over, part and this part, and we're going to combine it with try. Try means try do this, and if everything is fine, then continue. And if everything is not fine, then we're going to do what's over here. Except in case something goes wrong in this line, we're going to write int something went wrong. Please try again. And this is going to repeat over and over and over and over again, even if nothing goes wrong. We don't want this. So in case nothing went wrong in the first line, we're going to write a break here. Break means break the loop. Let's see if this works. I'm going to keep my fingers crossed and we're going to test it. So now let's type P, and then it should say something went wrong. Please try again and repeat. No. Number not defined. Let's say right. That makes sense. So what it's trying to do is trying to print this number even though something went wrong. Let's run again. B. Something went wrong. Please try again. C. 10. Okay, it prints the number. Perfect. Okay, let's see what things we can cross off the checklist. We learned about input and print, and we learned about try and accept. And we also learned about typecasting, forcing a certain variable to be of a certain type. In this case, we're forcing variables to be integers. Let's move on. Print an error message in case the user input is outside of a given range, and we're going to use if, elif, and else. So we still haven't made sure that it's less than 10, more than 10 and less than 100. So we're going to go over here and we're going to say if number is smaller than or equal to 10, then we're going to print number is too small. Please try again. Then we're going to say else if number is larger than or equal to 100. In fact, let's say rather like this: smaller than 10 or larger than 100. Print number is too large. Please try again. And in all other cases, we're going to break this loop. Save it and run. So let's say 9, say 101, say 50. Right, it seems to be working. Great. Now we want to do the exact same thing, but we don't want to use if, elif, and else. We want to use logical operators. So let's just delete this. And we'll say if the number is smaller than 10, or number is larger than 100, then we'll say print number is out of range. And in all other cases, we'll break the loop. So what, 9, range, 101, 50, say 99. So we can do it using just a single condition or two conditions combined into one. Or means either this condition is true or that condition is true. We can also do, instead of using or, we can use and. If both of the conditions are true, in this case, it would do the first thing, and in all other cases, it would do something else. So we have to switch up these two commands. C, Ctrl V, break. Let's say the number is 101, it's out of range, or 5, or 11, it seems to be working. Another logical command we can do is not. Not just flips a true value to false and a false value to true. So now I'm flipping this around again. Nine. Okay, seems to be seems to be working. Let's go back to our memory checklist. We learned about if, elif. We've learned about comparison operators like smaller than, larger than or equal to, and smaller than or equal to. We also have double equals. That means if the two values are exactly the same, it returns true, or not equal to. If the two values are not exactly the same, it returns true. Then we've learned about and. If they're both, if two, if you combine two Boolean value, Boolean is true or false value, and if you combine two Boolean values and they're both true, we end up with true, and in all other cases we end up with 1. With or, either or of them needs to be true, and for us to end up with a result of true, while with not, it just flips a Boolean value of true to false and a Boolean value of false to true. Okay, let's see. Next, we're going to talk about for loops. We're going to start with a value of 1 and double it n times, where n is the number given in the for loop. Each iteration we print, we have doubled x, resulting in y. So for 4, we're going to need a range value. This command gives us, let's say, uh, array. This command gives us an array of values, list of values. So the first one is 0. Second value is 1, etc. You can also use len function to give us the length of the array. It's 10 long. So the final value must be 9. The array value with the index 9 must be the last one. So range 10 gives us a list of values 0 up to 9. We can also we can't really read it here. Say a start value 8 and an end value and a step. So now we have the first value, the value with index 0 has a value of 8. Second value with an index of 1 will have a value of 10, etc. And it will go all the way up to 20. So what does that have to do with a for loop? Well, when we create a for loop, we say for I in array, which we just defined using the range. That means we take this array and for each index value inside it, for each value inside this array, we're going to do something. So we're going to print I, 8, 10, 12, 14, 16, 18. For each value in the array, we do something. So now we want to double something. So we're going to start with the initial value. And I'm going to say, a variable with a value of 1. That's the initial value. And we're going to say for I in range n. How many times, how big a range do we want? We want number, whatever the user input. We're going to say we're going to double it. So value is equal to value multiplied by 2. So the new value of value is equal to the old value of value multiplied by 2. I is going to update automatically, remember? So for each doubling we want to print, we have doubled x times, resulting in y. So let's create a message variable. We have doubled, and then we're gonna add I, that's the counter, and then we're gonna add to that value, the new value. And we're gonna run it, and it's not gonna work. But why not? That's the tricky part. Let's see what error message we get. Error message can only concatenate string, not int to string. So here we have I, which is an integer, and we also have value, which is an integer, and we're trying to add it to a string. You cannot add a number to a string, and you cannot add a string to a number, but you can add a string to a string. So we're going to force this number value to be a string. We do that with the str function. We also want to do that over here. Save it and run it. And let's say, hey, it's working. We don't have an error message, but we didn't print anything. So let's do that again. Print message. And let's hope we're doing exactly what we wanted to do. Right, it seems to be working. We have doubled 0 times, resulting in 2. We have doubled 1 times, resulting in 4. Remember, these are all the value of I, so it's not really correct. Remember, it's when we use range, it actually starts at 0. So to fix that, we can say we don't want to start at 0, we want to start at 1. And we want to end at number plus 1. Start our range at 1 and we end our range at whatever the user put plus 1, because you'll see. Normally I like to add these little prints lines so that I can see what's going on just in case I'm making a mistake. This helps me to debug a lot. Another thing we could also do is keep it like it was. And just add a plus 1 over here. Perfect. Okay. Find out how many times you can double the value 1 until it exceeds 1,000,000. We don't need this anymore, so I'm just going to delete it. And we'll just say target equals, save it. An initial value equals 1. We're going to double this x times until we get a value of 1,000,000 or more. Let's see. Let's use a counter. We're going to start with a counter. And the initial value of the counter is 0. Then we're going to do another while loop. And again, I'm going to put no condition up here. I'm just going to put true. And let's see. Value. New value equals the old value multiplied by 2. Counter, we also have to increment. Counter equals counter plus 1. And then we're going to print our message, which is we have doubled plus. Don't forget the string. To cast as a string. Counter. We have doubled counter times resulting in plus string value. Okay, I forget I left one brackets over here. Now this loop is gonna go on forever. We don't want that. Let's see what that looks like actually. Oh, it's terrible. To break, Control C. Good. We need to put some kind of exit condition in here. Let's see, what was it? Until it exceeds 1,000,000. So we'll go if value is greater than target. In that case, break. So we need to double 20 times. Once we double 20 times, we end up with a value larger than 1 million. Makes sense, right? Okay, let's do the last one. Get the user's favorite color. Use match case. So I don't think we'll need to use match case in the exam, but it doesn't take much time to learn it, so let's learn it quickly. First of all, color equals input favorite color. And then we're going to do match color case red uh, print. You're passionate. You are passionate. Let's test what we have so far, see if it works. Okay, it works. Let's just copy, paste. Ooh. You're dependable, you're reliable, or whatever. Case other print color unknown. Blue. Oops. Yeah, it works. That's how to use match and case. So let's have a quick look. Match and case we learned too. We also learned to cast a string. And we learned about range. And we learned about for. We learned about while too, but we didn't really learn how to add the condition. But it's very easy. You just put the condition between brackets at the front. So I'm just going to check it off. And we learned about break as well. In fact, I was planning to remove this from the checklist, but it's still here. So I'm just going to quickly demonstrate how to do random. But you probably won't need it on the exam. But you never know. To import, you just type, we need to import random first before we do this. Let's just run this to import it. So now we've imported it. And here in the command line, we're going to experiment around with it. Random dot. This means access the random object. Don't worry about what that means. We're going to learn more about objects later. But once we press dot, we can press control and space, and that's going to give us a list of choices. If you forget, you can always do control space. And now we've got rand int. It sounds like we're going to get a random int from this. It's going to open brackets, and unfortunately we cannot see down here, but normally you'll be able to see. But let's say 10, 100, and enter. And as you can see, we got a random integer between 10 and 100. And if you need another kind of range, like a real, you can always just divide by 100 if you need a percentage or something. And that's basically all we need to know for random. So let's go over here and check that off too. Okay. Another thing we didn't talk about, but we may as well talk about quickly, is comments. To type a comment, you just use hashtag. Compiler throws away all comments. You probably know about comments already, but just in case you don't, the compiler just throws them away. They have no impact on the functioning of the code, but they're super useful to communicate with other programmers. and they're also super useful to communicate with yourself from the future, because 10 years from now you're probably not going to remember why you did a certain thing, so you leave comments for yourself to remember. We go here. If you want to comment out multiple lines, the easiest thing to do is go like this. Type everything in between. But in Python, in idle, you can even go to format, comment out the whole region, and it adds comments to everything. Or uncomment. Also, it's super useful to go over here to options and show line numbers. Okay. I think that's all we have for basics. Let's move on to arrays. Declare an array with values A, B, C, 1, 2, Z. So this is unusual. In Python, we can mix arrays, mix the types inside the array. In other programming languages, you can either have an array of integers or an array of string or an array of chars or whatever. But in Python, it's super easy to mix it. So I'm going to create a new file and I'm going to save it as arrays. Let's get started. Put it up here. Uh, let's just do it manually. Okay, we want to declare an array. So we're going to say my array equals square brackets, and then just put each element in separated by commas. B, C, 1, 2, Z. Okay, loop through the array and print each area. We're going to do for I in range, and as the length of the range is going to be the length of my array. And we're going to print my array of I. So we're going to, this is, I is going to be 0, 1, 2, 3, 4, etc. So the first element is 0 and it's A. The second is B and the third is C, etc. So let's print. Remember, if you're an idle and you get kind of lost, you can always do experiments like this, like my array, what's the second element? Oh, C. Oh, that now I remember you'll say it starts counting at 0, 0, 1, 2. C, that's right. So you can do experiments like that to help yourself remember. Next, we're going to talk about 2D arrays with the values below. So an array can be a two-dimensional array. Let's start with the first row. Name. Biology. Great. English. Great. That's the first row. And now we've got my array. And the first value is name. The second value is biology grade. Third value is English grade. And what's the fourth value? Error. So when you get an error message, it's always a good idea to read it so that we can uh, get familiar with the different types of error messages, and then we can more easily uh, debug. In this case, list index out of range is an error message you might get a lot. It basically means we're trying to access the index of an array which does not exist. We only have 3 indexes here, but we're trying to get the 4th one. Okay, moving on. We've got one row. Now we want the second row. So we're going to put an array within an array, multiple arrays. So we're going to start a new array, and this is going to be our first row. Our first row is an array in and of itself, so let's paste. And then the second row is going to be here. The second row is going to be John, first element in the array, 969. Excuse me, 9, 6. Let's save it and run. Let's type down here my array. As you can see, we have 2 arrays, and both arrays are combined within a larger array. It's a bit hard to read if I do it all in one line, so that's okay. We're just going to press enter here. And we're going to do comma. And we're just going to copy and paste it. Copy, paste, 1, 2, 3, 4 students. And I'm going to update the names. Michael, Mary, and update grades. Now, I have the full array. When we want to access these, we go like this. My array 0 means access the first row. Access the second row, etc. If I want to access the first column, I'll go like, well, let's say the second column of the first row. We do first row first, and then we do the second column. First row, second column. So if I want to see the entire column, we just use this double dot. And we have, excuse me, that's the entire row. Okay, good enough like this. Let's see. Use a loop and an if to look up Michael's grade. So assuming we don't know how the array is populated, we can write a loop. So we're going to say, how long should our loop be? Well, let's say we don't know how many students we have. In this case, we'll do while and then have an exit flag. Exit flag. Oh, you know what? Let's just do it the simple way. Let's just do while true, and then we'll use a break to determine the exit. First thing we're going to do is we're going to say get the name, right? So we're going to do my array of my And we need a counter as well. So let's go up here and say the first value of I is 0. My array of I equals my array of I. And then we'll say if name equals Michael. Oh, excuse me, not this double equal sign. If we remember from our memory checklist, we need to use a double equal sign to check if the values are identical. If the name is equal to Michael, in this case, we're going to print I, the ith row. Well, what is that we want? We want the English grade, which is the third column. So we put 2 over there. And then don't forget I plus equal 1. This is the same as saying I is equal to I plus 1. So let's run it and see what happens. Can you predict what's going to happen? We've got index out of range. And we actually did not print the value. Okay, let's print name every time. Of course. Printing the whole row. So we don't want the whole row, we just want the first item of the row, like this. Okay, so now we printed 7, and then we printed, then we got to Mary, and then we got index out of range. So we can, let's see. We have 5, 1, 2, 3, 4, 5. So while I is smaller than or equal to 5, should work like this. How about smaller than or equal to 4? Right, okay. We can also do with Mary. Good. Now we can remove this. We don't need that part anymore. Oh. We can also declare big arrays. We're going to declare a big one. We're going to do one with 50 rows and 10 columns. So let's say the first row has 10 columns. So we're going to say my array, and we're going to say none equal none for I in range 10. That's going to create an array. Oh, I forgot these. This is going to create an array of nones, which is 10 long. One, two, three, 4, 5, 6, 7, 8, 9, 10. We don't have to create an array of nodes. We can also create an array of like the number 4, like this. Let's just print my array. Or we could create an array of A. But the assignment says create an array of nones. 10 long. But we don't want it to be only a one-dimensional array. We want a two-dimensional array. So we're going to put this whole thing in array brackets, square brackets. And we want this entire row to be duplicated multiple times. So we say for I in range 50. And now we have like a super big array, a 10 by 50 array. Let's see if we can access this. Let's say we want the 10th row and the 50th column. All the way in the bottom right corner. It's out of range. Why? That's because I mixed up rows and columns. So we have to do it the same thing, but the other way around. I always mix it up. I always mix it up, but that's okay because you don't really need to memorize it. You just need to be able to fiddle around with it until you get the right answer. So we have 50 columns, 9 rows. We could also do it the other way around if we want. It doesn't really matter. If we do it the other way around, we have to switch these around too. We have to say the row number first and then the column number. The exact same thing. Okay. Incidentally, we can also set the bottom right value to something if we want. That sets it like that. Let's see, print my array. And the very last entry should be A. There we go. Okay. It's abstract. It's a bit abstract, I know, but don't worry. You practice. You'll understand it better and better. Okay, file, save as, functions. We're going to create a new one. Let's see what we have. S. Well, let's have a look at the memorization checklist. 2D arrays. Next, we're going to learn about functions, and in the meantime, we're also going to learn about some of these string functions. So functions are very simple. It's just a bit of code, and it never runs unless you call it. So let's see. We're going to write a function that asks the user to enter their name and then print hello plus name. Very simple function. In Python, we just type def, the name of the function, and in this case, we have no arguments to pass through. We have no parameters to pass in. Print, name equals input. What is your name? And then we're going to print hello. And now let's run this, and what's going to happen? Oh, excuse me. Nothing happens. Why does nothing happen? That's because we've defined this function, but we're not calling it. So we're going to call it. Need this brackets because functions always have arguments. In this case, it has 0 arguments, but we still need the brackets just to let Python know it's a function. What is your name? Paul. Hello, Paul. Good thing about this is once we've defined it once, we can run the function as many times as we want. Okay, and we can even put it in a loop and stuff like that. So we only write it once, we do it multiple times. Write a function that takes 3 string values as parameters. Def, and we're going to return the length. So we want as arguments. Some, I'm just going to call it some function, and we're going to say string 1, 2, we want to calculate the length of each string. So len 1 is equal to len of string 1. And then we want to calculate the average. Easy, right? And we don't only want to calculate the average, we also want to return the average. This is the output of the function. So let's see, let's call the function. Let's say output equals some function. And we're going to say ABC, DEF, GHIJ. And then we're going to print the output. Right. So whatever this function produces is going to be returned via this variable. So we need to give a variable name into which we're going to put the output of the function. Also, these strings are what's put in the function. We don't. These are literals, by the way, but we don't have to put literals. We can also put a variable name, like for example, we say name is equal to input. Please tell me your name. Then as one of these arguments, we're going to say name. And now we're going to write Paul, and it's going to change the outcome. So we have Paul, def, and GHI, J as the arguments. Okay, we're going to modify the function so that it calculates the sum as well, and it returns both the sum and the average. So how do you return multiple parameters? Let's see. A comma. Oh, sum is a reserved word. We have to be careful. I'm just going to put an underscore over there. And now we're going to do output. It's not just 1. Go over here so that I don't have to keep typing in my name. Okay. Let's run this and see what happens. Oh, so output is now 2 values combined in 1. That means I can't add to it because we can only concatenate a tuple, not int. A tuple is similar to a list or an array. So remember that can only concatenate tuple. That's probably because we've got some problem with round brackets. So what we can do is say output, comma, output 1, comma, output 2, output. Now we can say output 1, it's the first part. And we can calculate with that. Perfect. Another thing we can do is we can just do it like this as well. Output 1, comma, output 2. Of course. So that's how one function can output multiple values, how one function can return multiple values. Okay, next we're going to do a big experiment. We're going to make a bunch of variables. A equals pass by value. B, C, D, E. Pass by reference. Pass by C is global. D is local or not global. Let's say it's not global. And E is a mutable. What is mutable? That's what we're going to learn in a little bit. Okay. Oh, like that. Okay, def. Declare write a function that takes A as a parameter and passes B and passes a value B as a parameter. As an argument passed by value and as an argument passed by reference, and define C as global. Okay, so far so good. We're gonna say the function is called toUpper. C is global. We want to pass A by value and we want to pass B by reference. You may remember from last year what the difference is between pass by value and pass by reference. If not, we're gonna learn it now, so don't fret. Don't need to worry about it. And now we're gonna convert each of, so for now we don't need to care. For now we're handling the two is exactly the same. And we'll learn how to pass by reference using Python in just a little bit. So just be patient and let's just convert each of these variables into uppercase. So we have A equals A dot upper. Like let's say B equals B dot upper. C equals C dot upper. Let's print out each of these. First I'm going to print star for function call star close brackets in function call in function home and after function call. Oh my God. I don't know if you can hear that, but my son has a friend over. They're playing. They're really energetic little kids. Okay, so here we have before and after function call, but we didn't call the function yet. So let's call the function to upper. We have two arguments, A and B. This can change the variable name. That's okay. We're just gonna, for simplicity's sake, keep it like this. Oh, let me just put in a little space so that it's easier to see what's going on. Okay, so here we have A is lowercase, B is lowercase, and C is lowercase. And afterward, in the function, they all become uppercase because that's what we did to them. Uppercase, uppercase, uppercase. And afterwards, A and B have gone back to lowercase, while global has been changed. So the change has persisted. The change has persisted. So we pass by value. That means any change we do to the variable inside the function is not going to persist when the function is over. Pass by reference, we haven't implemented it yet. So in path by reference, the change is actually going to persist. So in other languages or in pseudocode, we would do like this: by var, a, and by reference. That would be enough, but unfortunately Python doesn't have passing by reference. We don't have the option. It's not a possibility in Python, but there is a workaround, and I'm going to teach you the workaround. So the workaround is simply to return the B value. Return B. And every time you run the function, you must be very careful not to forget to output B again and overwrite the local version of this variable with the new. And now let's see what happens. So we see that the change does persist. So passed by reference, the change does persist. Using global variables, the change does persist. Passed by value, the change does not persist once the function is over. So if you're a bit confused with pass by reference, I just recommend to stick to using global variables. It's much easier to understand, and it's very unlikely that you'll lose too many points. I think you'll probably lose 1 point. Sometimes on the exam, they specifically tell you to use pass by reference. But if you don't, you probably won't lose too many points. But on the other hand, it would be kind of a pity to lose that point. But you don't want to get confused and mess up the whole program and lose like 5 points just because you were too fixated on trying to get pass by reference right. So I recommend learn it, make sure you understand it, but failing that, just stick to global. If you get confused on the exam, just stick to using global. Okay, next we're going to talk about D. D is not global. D, we don't declare it as global, and we also don't pass it in as arguments. So we're going to say D is equal to D dot upper. Let's run it and see what happens. Oh, we get an error message. And this is another important error message because it comes up a lot when we're debugging. And you need to be familiar with it when it happens. So we get this error message here because it says cannot access local variable. So remember, if you see any kind of message like cannot access local variable, it's probably because we need to either declare it as global or we need to pass it either as a value or by reference. Okay, what about E? We're not going to declare it as global and we're not going to pass it as reference either. So we're going to take the very first element of E, the very first one, and we're going to say that is upper. And let's see what happens. Delete this. Oops. And as you can see, before the function, it's all lowercase. Inside the function, it's actually recognized. There's no error message, and it's turned to uppercase. And after the function, it's also uppercase, so the change persists. So what's the difference between E and D? The difference is that D is not mutable. All these variables like int, real, string, char, they're not mutable. That means they cannot change. Don't get me wrong, you can replace them and assign a brand new value to them, but you cannot change only part of them. Lists and classes, as we will see later, are actually mutable. I can change just a small part of it or each element of it if I want. That's why it's called mutable. So it's not that the entire, when I changed the first element to uppercase, it's not like the entire array changed and was replaced by a new array. No, the array changed. So mutable, so that's what we have to remember. Mutable, basically mutable variables are always global. Mutable variables are lists, like arrays, and also classes. These are two examples of mutable variables. So let's go and check this off. And let's go to our memory checklist. As you can see, we learned about arguments and returning a value. We learned about global. We learned about passing parameters by reference. And we understand about mutable and immutable variables. So let's close that. We also learned about the upper string variable, and we also learned about lower. But incidentally, we learned about len too. A string is basically very similar to an array. It's just an array of cars, and this exact same function len works in the exact same way. So let's move on to the next question. Next, we're going to talk about handling text files. So we'll save this as text files, save, replace, and let's Control A, delete, Control S. Okay, guys, so I actually had to move to another room than before. The acoustics in this room are worse than before, so the audio quality might not be great, but I hope you forgive me. Anyway, let's just finish this video because there's an exam in 2 days, and I'm sure you'll be happy if I finish it rather than today, rather than wait. Let's see, open the student grades.txt for reading. First, we need a file identifier. This is just a variable name, and we're going to use this variable name to refer to the file we're opening now. We're going to do open is the command, the function, and then the name of the file. And in the working folder, I have this file. I downloaded, or I created this file and put it in the same folder that I'm working on. So I don't need to worry about the path or anything like that. You can, if you want to download this file, you can download it from the link in the description. We put open file name as a text or as a string, and then we do the mode. And in this case, we want to open it for reading. This is R, it's for reading. Close. Control S. Let's run it and see if we get any error messages. We don't get any error messages. Next, declare an array of length 10 and width 3. Excuse me, what is going on? There we go. Okay. Declare an array of length 10 width 3. Let's just call it my array. Why not? And then we're going to say, I'm not talking about what to populate it with, so I'm just going to initialize it as an array full of nuns. Not like, you know what I mean, not like the clergy, none like this. For I in range 10, comma, no, for I in range. That's the width. And then the whole thing around square brackets. And let's run it. And let's test my array of 9, comma 2 should work. No, we have to do it vice versa. I always forget. Bam, bam, bam. Excuse me. Right. Okay, so this is giving the row and this is giving the column. No, sorry. This is giving the column number and this is giving the row number. If you want it the other way around, you just do like this. If you want row number first and column number second, you just do like this. This is what I always forget. That's why I just fiddle around with it until I get it right. So remember, I've got row number first and column number. Okay. Read each line of student grades and populate the first column of the array with the student names. Populate the second column is biology grade and English grade. And we have to read the whole file. Okay, so what are we gonna do? We're gonna start with a while, which I like to do because it's the way I usually create loops. I start with while true, and I don't really have to think much about the exit condition until later. Let's think about the exit condition. No, let's read one line. We'll read one line of the file. How was it again? File dot read line. That reads one line of the file. And we want to put whatever we read into a variable named line. And let's print it out. And let's test what we have so far. And I'm ready to press Ctrl C in case we're stuck in an infinite loop. Oh, this was not expected. File ID. Right. In fact, let's just call it file. To save on typing. Okay, we need to press Ctrl C. As you can see, it keeps reading and reading and reading, and the last lines are empty. So we're gonna put in our exit condition. We're gonna say if line equals empty string, if line equals empty string, that means we've reached the end of the file and we're gonna break. Okay. Now you see that we have an extra line space between. To get rid of that extra line space, we're just gonna go like this, strip. Good. We also see that the first line is a header, and we're not really interested in the header, we're only interested in the data. So we're gonna read that line ahead of this loop, without putting it in, without putting it any data or anything, without processing. I'm just reading it and getting it out of the way, and then you start a loop, and it's going to loop for the remainder of the file. Okay, very good. Next, after the break, what are we going to do? We're going to get the name. And in order to get the name, we have to find the first comma. So I'm going to say n equals string dot find, and then the character that I'm looking for. I need to make sure it's giving me the desired result. Yeah, so first we get 4, then 5, then 4, then 4, then 5, then 6. Makes sense, right? Now we want only the name. Name is the first 5 letters in this case. So we're going to take line, and we're going to treat it like an array. We're going to take only the first 5. So it starts with 0, and then we get all the way up to n. And then we're going to put it in the array. My array of row number from a column number. Column number was 0. But we don't have a row number, so let's add it up here. The initial row number is 0. And all the way at the back, once we're done with all of this stuff, we'll increment the row with 1. Row plus equal 1. This just means add 1 to row. Let's cross our fingers and see what happens. Or in fact, after we're done, we're going to print my array. And very important, cross your fingers. I'm going to press F5. Let's see. Oh, it doesn't work. Oh, I'm such an absent-minded fellow. I forgot to put in here the name value inside the array. Because I'm so absent-minded, that's why I always test all the time. And I recommend you too, because it's easy to make a small mistake. You test very often, you'll easily find the small mistake. If you write like 100 lines of code, there's going to be any number of small mistakes. And it's going to be like finding a needle in a haystack. Okay, so we've got name, and now we want the next, which is the bio grade, which is this number. So we are going to have a quick look at, we're going to remove the first part of the line. So we're going to go line equals line, and we're going to start with n plus 1. We're going to end with the length of the line. So it basically means all remaining characters. Let's print just to see if this is going to do the trick. Yeah, okay, let's remove all the other print lines because it's kind of making our debugging harder. You don't have to remove them, you can comment them. Let's see. Oops. Yeah, okay, it's working. It's every time it's up to the first comma. Now that we have a new line, we're going to find another comma. So we're gonna do n equals line dot find. And now we can get both the bio grade, or was it bio first, right? All the way up here. Anyway, Yeah, bio first, then English. Okay, bio equals, uh, what was I doing there? Line. We got a new n, so we start with n. Now we start with n plus 1. No, we start with 0. Bio is the first one. It's starting all the way at 0, all the way up to n. And then we've got ing is equal to line of n plus 1 all the way up to the length of line. And now, like I said, we have to just quickly check that. And hopefully I didn't make a mistake, but you never know. I might have to fiddle around with it until it works. Okay, so we've got the first one is 9 and 8, 10 and 5, 5 and 6, 4 and 5, 6 and 10, and 9 and 9. Okay, it seems to be working. That's great. Let's delete all these prints. And finally, let's put the name in the row. So we're going to say my array at the current row and name the first column is bio and the second column is English. Okay, so it seems to be working. And what I always tell my students is as soon as you open a file, immediately close it and put it all the way at the end. And I forgot my own advice because I was just going to forget to close the file. It's best to close it immediately because in the heat of the moment during the stress of the exam, you're gonna forget. So do it straight away so that you have two chances to not forget. You usually get 1 point on the exam for closing the file. You forget, it's just a pity you lose 1 point. It's still not the end of the world because you don't need to get all the points to get an A. Okay, next, create a new file, whole class summary.txt, and write the following line to the file, then close the file again. Okay, so we're going to create a new file. I'm just going to use the same file ID. Open again, the name of the file, whole class summary.txt, and this time it's for writing. W is for writing. Okay. What was my advice? Close it straight away so I don't forget later. And even if I do forget to close it now, I might still remember later. Okay. Oh, we're going to write one line. So we're going to do file.write line. And we're going to say summary for class 6A. The good thing about this is when I write it, if this file already exists, I'm going to overwrite the file that already exists. However, if I write it just multiple lines after I've already opened the file, it's going to write consecutive lines. So if you're starting a new file from scratch, you just do W. If the file exists and I want to start from scratch, you use W. If the file exists, but you don't want to remove what's already in the file, you just want to add to the end, you use A for append. Anyway, let's run this, see if I get any error messages. Oh, I do. Right line. Right lines. Okay, it should work. It should be working. Next, let's check. Here we have whole class summary, the file we just created. And let's open it. And as you can see inside, we have the one line. We can add multiple lines, that's fine. But when we close it and open it again, if we do it with W, then it's gonna replace everything we've just written. So now we want to open it again, but we don't want to replace what we've just written. We want to add to the end of the file. So we're going to go File equals Open. And let's pick the whole thing like this. And instead of W, we'll do A. And don't forget, we're going to file.close immediately to guarantee ourselves the 1 point. Next, we have what we want to do, calculate the average of each student. So we're going to loop for the array, which we have. And you know me, I like to do like this. And then we're going to say, put in our exit condition if my array, let's do row, let's start with row is equal to 0. If my array row is equal to none, then break. Okay, so now we've got the exit condition. So now let's go through the loop, the array one by one and calculate the average grade. So we're gonna start by saying AVF, short for average, equals my array, the current row, and we'll get 1. That's a bio grade for the current student, plus all of this. Two. Divided by 2. Save. Okay. After we calculated the average, we want to write to the file. But just to make it a bit easier, we're going to define a new variable called message. And it's going to be a string. And what do we want to write? Let's see, the student's name followed by their average grade. So the student's name is my array of row, comma 0, plus, and let's just add a little comma, plus, ever. And I can already see that something is going to wrong. Something is going to go wrong. Can you figure out what's going to go wrong? Let's see. Error. Unsupported operand types for string and int. So we know it has something to do with string and int and this backslash. And which line is it? It's in line 40. Hold on. Line 40. So it's something to do with this and something to do with using strings or ints. And I'll give you the clue. When I read this, I just took a number, but I didn't specify that this number is supposed to be an integer. So instead of putting in, so we just put a character, letter value, or number value that's known as an ASCII character in the array. So in order to force it to be an integer, I'm going to modify the code, and it's going to look like this. That forces the values I get to be an integer. Another thing you could do if you want is just leave them as characters or text and then put the integer over here. But be careful, the final average needs to be a real value, so we need to just do the sum should be an integer. If we did it like this, it's gonna round, yeah, excuse me, that's not gonna work either. We need to do it like this. it for some integers before we add them together, or it's never gonna work. Something super weird is gonna happen. Okay, let's control Z that, and it should work like this because we have forced them to be integers up here. Oh, it doesn't work. Can only, excuse me, cannot concatenate string. Right. Now, after we've calculated the average, we have to put it back to string. Because we're writing, you can only write string values to the, you can only, excuse me, you can only add. We got a text over here and we're adding we cannot add a number to the text, we have to add a string to the text. Now it should work. Okay. Let's check our file and see if it's working according to. It's not working because I forgot to write the file. Okay, we got file dot write lines. We've got our message already. Let's check if it's working. Control save, Control S, fingers crossed, run. And we can see a whole bunch of data has been put in our file. Let's see. Oh, it's not working again because I forgot to update. Oh, I have to Control C. Oh, file is growing. Yeah. Forgot to update the row number. Unbelievable. This is awesome. I'm so sleepy today. I need more coffee. I need more coffee. Unsupported operand. Plus, we cannot add a none to a plus. Okay. Why does that happen? That happens in line 40 as well. We need to. Why does that happen? There must be a good reason. We're supposed to be breaking over there. Let's figure it out together. Print. Oh, of course. Okay, here we go. I forgot to get the name. Yeah, that should work. Oh, fine. Now let's test it. Okay, very good. The only one more thing I want to change is actually this is all on the same line, so we want to add another line. Let's see, let's add another line. Do plus, backslash, and that's the general symbol for new line, line feed. And now we have it in a new line. Also summary for class A, we want to put a new line over there as well. Backslash n. There we go. Okay. So let's have a look. We finished this. Let's see what we've learned. We've learned about read, write, and append. This should be right lines, excuse me. We've learned about close and we've learned about handling end of file. So that covers that. And we've also learned some more functions like this and this and this. And to use a string replace, let me just quickly show you. Let's define the new string. My string equals hello. And we want to replace hello with hi. Control space, open that, hold with new. Probably won't need this on the exam, but you never know. And then let's print a string. Oh, I'm stupid. We say new string equals and then print string. There we go. I hope you can reverse engineer what I just did and understand it. We probably won't need it, but better just be on the safe side. That's it for a lot of stuff. We only have two topics left: classes and file reading and writing in binary. So next, let's move on to classes. So we're going to our question. I'm going to save this as oop.py. Select everything by pressing Ctrl A and delete and Ctrl S. Create a class caveman. The class has the following private properties. So to create a class, we just say class caveman, the name of the class, and double dot, and that's all. But we need to create an initialization function. So every time we create a new instance or a new object using this class, it's going to call this initialization function every time we create it. In fact, in general terms, it's not an initialization function, but it's called a constructor. So let's see, def function. The constructor in Python is always double underscore init, short for initialization, double underscore. And then we open brackets and we always use self. Always add self to every function you add to your class. And then double dot. And for now, let's see, we have a Boolean called hungry, so we do self dot hungry equals, and automatically the automatic value is true. Let's run what we have so far. So we have, we're going to make a new caveman called Glug, and he is going to be a caveman. Like this. We've got Glug dot hungry is true. We can set the value to false as well. That's what I meant. And now when we ask for it, that's a very simple property. Only be careful, this property is supposed to be private. So in order to make it private, we're going to add double underscore. And let's run it again. And this time, when we say glug.hungry, get an error. Oh, excuse me. That's not the error I was expecting. That's the error I was expecting. Has no, excuse me, time. That's the error I was expecting. It has no attribute called hungry. It's private. We can only access it from within the class itself. We cannot access these private variables from outside, which is encapsulation. This is called encapsulation. We also have a name. The name is the name of the caveman, and it's supposed to be Here, hungry is set to true by default, and when the caveman is created, we're supposed to give the name of the caveman. So we're going to add an argument to the initialization function, and that's the name. So the first thing that happens when we create, excuse me, the first thing that happens when we create a new caveman is it sets hungry to true and it sets the name to whatever name we put. And we're going to do one more thing. We're going to print name plus was born. When. Then we're going to run this and let's create an instance just to test. And we specifically have to give it a name. Glug. Glug's name is Glug. Glug was born. Wah, wah. Okay, perfect. Great. The constructor, da, da, da. Okay. The class has one public method named eat. This method sets the value of hungry to false. So remember, we cannot access this variable from outside. So if we want to change it to true, we have to create a function which accesses this variable. And we're going to create a function like this. And we would just say self dot hungry equals false. And we're also going to print gobble, 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 gobble. Just so that we know that Glug managed to eat something. And let's run it. And we're going to create a new caveman. And we're going to say glug.eat to test if it's working. Yep, it's working. Okay, what's next? We got to make a getter and a setter. And now just two getters. We're going to make is hungry. Def is hungry. Always add self, remember, and all we're gonna do is return self dot hungry. Def get name. All we're going to do is return the name. So we can use these getter functions. So even though these variables are private, we can use the getter functions to get their value. The good thing is we cannot set the value. So anybody using this code might make a mistake if they accidentally set the value to something stupid like self.hungry equals a little bit or something like that. No, the code can only handle true and false values. But if the intern comes and messes with your code, the chances that he does something wrong are much smaller thanks to these getter values. This is one of the main advantages of encapsulation. It gives access to the code, but it gives limited access so that people who don't know the code very well are less likely to make an accidental mistake, ruining the whole code. Okay, we got the two getters. The class name also has a destructor. The destructor is called every time we delete an object. Def, and this is also a dunderscore method. Dunder means double underscore. It has underscores in the front and in the back. We also want self as a. And all we're going to do in this case is say, oh no, the saber-toothed tiger ate me. We're just going to print that. I'm going to charge my laptop. Oh no. saber, tooth, tiger, 8 plus. Excuse me. And now let's run it and test it. In fact, I'm just going to test it here. Plug is hungry. Print plug.eat. Print plug is hungry again. And then let's print plug.name as well. Get name. Then let's delete. To delete glug, we just press use the keyword del for glug. We barely knew you. Okay, let's see. Glug was born. He is hungry. He eats. He's not hungry anymore. That's his name. And then he died. It was not a very long life, but he lived it to the fullest. Okay. Create a new instance of caveman called Glug, which we did, and we deleted him too. We did that too. Now we're gonna create a new class called Modern Man. Class Modern Man. Class Modern Man actually inherits Caveman. So we open brackets, put Caveman in there, and close brackets. Then, what are we going to do? We are going to say pass. Pass means we leave it empty for now, and we're going to run some tests. We're going to create a new person called Greg, and we're going to say Greg is a modern man. Open, close brackets. We don't have anything in. We need to give Greg the name because Greg inherits the same constructor as caveman. So we have to give Greg his name, Gregory. Hello, Gregory. And so far, Gregory actually behaves in the exact same way as a caveman. But as you know, modern man behaves slightly different from caveman. So let's see how he changes. Let's see if Greg eats too. Just to demonstrate, he can also eat. But one thing you should be aware is he cannot access any of the private variables because it's in the superclass, it's in the Greg's parent class. So even though Greg inherits caveman, when it's private for caveman, it's private for caveman. And any class that inherited it cannot access it. So Greg is gonna need these getter functions as well. Okay, we'll see a bit more about that later. Okay, we get the following additional property and we get the following additional method. So let's see. In order to make an additional property, we need to initialize again def double underscore init double underscore and then open brackets self. We're gonna need the name again, close brackets. What we're doing now is we're overriding this method. We want to do the exact same thing though. We want to call the exact same function. So we're gonna say Super means look at your super class or your parent class from which you inherited stuff. And then we're going to press dot, and then we can call this method. Init. And we're going to call name. And it's going to do the exact same thing. So far we're doing the exact same thing. Let's run it. Let's test. Right. Gregory was born. But in addition to that, we're going to create a bank balance. Self dot double underscore. His bank balance is private. Now it's 0. But he's a baby. He doesn't need money yet. Okay, let's just print to clarify that the bank balance, that we've already done something additional. Let's see. Yeah, so we did this, which is in the superclass. And we also did this, which is only for modern man. Okay, what else? We got your bank balance. We need the function show balance. Def show balance. Self print self dot bank balance. Let's see. Reg dot show. Good, it's working. Modern man also eats in a much more polite way, unless he's hungry. So we're going to override the eat method. So to override, we're going to do the exact same thing as, we're going to create the exact same function with the exact same function header. And whenever we call this function, Greg, it's going to call this function instead of the original caveman method. And in this case, what we're going to do is we're going to print true. And here, let's see, Greg.eat. So as you can see, when we call Greg.eat, it chews instead of just gobble, gobble, gobble. Let's see, what else do we need? We said that he's only going to chew if he's not hungry. If he's hungry, his caveman instincts is going to surface up again. So we got to do something like this. If self dot double underscore hungry is equal to true. In this case, we are going to call the super function instead. If not, we're going to do like this. And chew. Is this going to work? Handy hint, it's not going to work. Let's find out why. It doesn't work because, as I told you, this is private. And even though modern man actually has this variable, it inherited it from caveman. It's private in caveman. So we're going to have to use this getter instead. So instead of saying underscore hungry, we have to say is hungry. This. Now, when it called the super, it automatically changed the hungry value to false. So if we eat twice in a row. The second time he eats, he's gonna eat like a modern man. So the first time, because he's hungry, he's gonna eat gobble, gobble, gobble. Second time, chew, chew, chew. Okay. Modern man dies. He doesn't care about the saber-toothed tiger, but he wants to update his last will and testament quickly before he dies. So in order to do that, we're going to override the destructor. So we go over here, there it was, and we give, as usual, self. And instead of that, instead of what we normally say, is we're gonna say name plus updates his, her last will and testament. And then we're gonna delete Greg. Oh, that's a bit. Self dot get name. Right. Oh, and I forgot the space. Now we're going to add a method called earn money. And the method can be called with no parameters, in which case by default we're going to add 10. Or if we want to specify by how much Gregory has earned, we can give that as an optional parameter. This is called overloading. So one function behaves differently depending on the number of which parameters we get in. You can't really do it in the normal way in Python, but we can do it in a different way from usual. So normally we would just define the exact same function twice, but on one we would use integers as an argument, and on the other we would use strings or whatever, or a different number of arguments. But in Python we have to do it like so. Def, what was it? Earn money. Now we've got two inputs. Or we've got zero, or we always have self. And then we have, that's all, right? But optionally, we can add another input, which is the amount. By default, the amount value is going to be equal to none. So this just means that I'm allowed to leave this empty. And if I do, it's going to get the value none. Now we go like this. If the amount is equal to none, in this case, we're going to add 10. That's the default amount. Self dot bank balance plus equals 10. Or if we add, if we do specify the amount, then we do self dot bank balance plus equal amount. And that should work. Let's test it. So how are we going to test it? First, we're going to say Greg dot earn money without specifying the amount, and then we're going to say Greg dot show balance. Then we're going to do it again. Greg dot earn money, and we're going to specify 12. It's going to earn 12 whatevers. And we're going to show the balance again. So first it will increase by 10, and then it will increase by 12 the next time. Run. There we have it, 10, and then increase by a further 12 equals 22. Okay, so that's all about overloading. Let's move on to the next topic, handling binary files. binary files. A, delete, save. Create a class named student with the following properties. So this class is going to turn out to be a record, and we're going to read and write records to and from the file. But before we do that, we're going to create the class. It's just like what we've just learned. A class named student, and we only have two properties. You can have many properties, as many as you want. Just think of it as a record. We can have name, student ID, the classes they're taking, their grade, etc., etc. But we are just gonna say like this. We're gonna let, yeah. And we're not gonna make it private. We're just gonna make it public so that we can easily change it. What was it? Self.name equals the default name is just empty, and self.student ID, student ID, and the default student ID is 0. Next, we're going to create an array of 5 students. Wait, I'm stupid. Before we continue, I want to just go over the checklist. We learned about init, their properties, aka attributes, methods, double underscore means private, inheritance we learned about, overriding we learned about, using the super keyword we learned about, and del, destructors. Here we go. Next we're going to learn about reading, writing, and appending to binary files, and we're going to use pickle. And we're also going to learn about OS. Anyway, let's continue with the question. I'm going to create an array. I'm going to call it array students. And our array consists of an array of student for I in range 5. There we go. We want to give each we now have an array of empty students. And they all have no name and a student ID of 0. So let's give each student a name and a student ID. Equals arc. Oh, and 0, 0. And let's copy it. 1, 2, 3, 4, 5. George. Amy. Clara. Anne. And 1, 2, 2, 3, 3, 4, 4. Let's test it. Array students of 2 dot name array students 4. Perfect. It seems to be working. Create a new file and add mark to it. Then close the file. So first things first, import. Import Pico. Pico is going to help us write these records to file. And we're going to say file equals open. I'm going to give the file name student records. .bin. You can call it .bin, binary, or .dat for data, whatever you want, really. Just don't use one of .bin or .bat is fine. Just don't use .txt or anything like .exe or .svg or anything that's already in use because that's gonna be confusing for people. It could cause unexpected problems. And we're gonna write, W for write, and also B for binary. And then the very first thing we're gonna do is we're gonna close the file. We're gonna add mark. Let's have a quick look. Do we already have such a file? No, we don't have this file yet. So let's run it. So let's go file. Control Z, Control Z. So what we want to do now is we want to add the file, the data we have, and we're going to use pico.dump. So we've opened the file, I got pico.dump. Dump means just put the data into the file at the, because we're using W, it means we're going to start a new file. And which data are we going to put there? Array students, very first one. And now we're going to give the file name, the file identifier, which we put over there. Let's cross our fingers and run. It seems to be working, no error message. Here we have it. We've got student data, and when we hover over it with a mouse, we see that it's 71 bytes. If we run it again, student data is still exactly 71 bytes because every time we run it, we're overwriting the file. Okay, next question. Append the file with George, Amy, and Clara, then close the file. Exact same thing. Instead of using write though, we're going to use append. And we've already written in Mark, and now we're going to write in George too, and we're going to write in Amy, and we're also going to write in Clara. And let's run it. Let's go back to our file. Hover over it, and we get 286 bytes, which is approximately 4 times what it was before. So we can see we have more data in our file now. Okay, next question. Read the third record from the file and print the ID. To read the file, we open it first. And we close it as well. And instead of using dump, we use load. And we also have to put it somewhere. So I'm going to put it in a variable called myStudent equals file dot, no, excuse me, pickle dot load. We're going to load from the file, right? After that, I'm going to print the file I have, print the student I have. So let's print just to see which student I got. My student dot name. Which student did I get? Okay, I read a student, but I read the very first student. What happens if I do this load twice? It's a second student. What if I load three times? Students, etc., etc. What if I load four times? I think you're getting where this is going, but what if I load five times? Error message, ran out of input. So we want the third record, so we have to load three times. If you need the 100s method or whatever, you need to create a for loop and read each record. Okay, have the user input the student name, read the file and search for a student with that name. Output the student ID of the student or output file not found. Let's see, we are gonna use a while loop. We're gonna get the name first. Name equals input name, please. We're gonna do while true. We can delete this. Okay, now what we're going to do is we're going to say we're going to start reading the file. So in fact, we can start reading the file already before the while loop, and we're going to close it after the while loop. Next, we're going to read. We're going to read one record. And we're going to go and say if my student equals dot name equals name. In this case, we're going to break and we're going to say we need to print the student ID. And student dot student called student ID. Let's run. Let's start with Clara. Yeah, Clara has a student ID of 9, right? That makes sense, right? Okay. However, what happens when I'm looking for my own name? Error, ran out of input. How do we avoid this? Except print run it. Oh, proceed. Again, of course, break the loop. Perfect. Okay, final question. We want to insert student n into the file so that the students are arranged in order of student ID. So if we wanted to insert n and we were serially storing the files, the records, that's fine. We would just append n to the back. But that makes it a bit harder to find any of the students. So let's rather sort them in order of their student ID. In that case, as you can see, we need to store it after Mark and before George, so that they're stored in that order. And when we need to find a student with a particular student ID, it will be much easier to find her or him. So let's do it. We are going to, so what we're going to do in this case is we're going to get each record, read each record, and check the student ID number and see if we need to import and or not. Let's see. And then after that, we are going to, if we do not need to import and, we're going to put the current record to another temporary file, and we're going to keep doing it like that. So we need to open two files. I'm going to start with file equals open student record. And we're going to open it for reading. And file.close. We're also going to create a new file for writing. File 2, open temp.dat for writing to binary. And we're going to close file 2 as well. And now we are going to go and start a while loop. While true. First things first, we're going to read. I'm going to try to read. We're going to try to read student. And if it does not work, we're going to assume that we're at the end of the file. If we're looking for a specific error, by the way, we can go like this, DOF error. So this is only going to happen when we get an end of file error. If we get an end of file error, it means we've reached the end of the file and we still have not dumped our file. So I'm going to do pickle, dump. What are we going to dump? We're going to dump, and we're going to dump array of student.4. Into temporary file. Okay. However, in all other cases, we have to have a look at the student ID number. So I'm going to say if my student, but student ID is larger than the one I'm dumping, in this case, we're going to dump first the student ID, which I'm dumping, and then straight after that, we're going to dump my student. And then after that, I don't want to stop, I want to keep going. But I only want to keep going until we've reached the end of the file. In fact, what I just realized is that in case I dumped it here, in case I dumped array students 4 here, and I reach the end of the file, it's gonna dump this twice. So I want to avoid that. I'm gonna make a new boolean and I'm gonna say dumped equals to false. So we start off with it not being dumped. I'm gonna say in case we dumped it, we're gonna turn it to dumped equals true. And then we're gonna keep going because we want to transfer the remainder of the files too. Here we're gonna say if dumped equals false. Only in this case do we dump the file. If it hasn't been dumped yet and we've reached the end of the file, then dump it. And then after that, we're gonna break the loop. Break the loop. I think it's gonna work. Ah, that's just also for good measure. Say dumped equals. We don't really need to do this, but for good measure, just to avoid confusion in the future, we want to give Python the knowledge that we have successfully dumped it. I think this should work, but it's kind of a tricky one, so let's run it. Okay, first of all, let us just say here, and so I don't have to input every time. Now let's see. Oh. We've got a temp file that's 428 bytes, and we've got student records file that's 286. Let's see, we're gonna debug. Let's see if we're making a mistake or not. We're gonna open file 2. We're gonna read it, and we're gonna read. This is just to check if we had the right data. pickle.load, test equals pickle.load, file 2, and let it test dot name. And we're gonna do it. We should have 5 records. We're gonna do it many times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see. I forgot to print. Right. There's definitely something going wrong. Let's have a quick look. Okay, so what we're doing wrong is we are only first of all, we're only dumping it if the student ID is larger. I mean, we're dumping it every time the student ID is larger. So first of all, we have to say and not dumped. So we're only gonna dump the new to be inserted record if the student ID is larger, and we haven't dumped it yet. Second of all, we want to continue dumping the files even though in any case We want to continue dumping the file we're reading from the record which we're reading from the original file, whether or not we inserted the file before. Let's see, hopefully it's going to work now. Let's see. 1, 2, 3, 4, 5. Great. And Anne has been inserted just before George and just after Mark. That's great. Let's see though, is it also going to work if I change the student ID? So instead of it being the second, it should be the very first. Let's see. Yeah, it's working. What if it's supposed to be the very last record? If it has a higher student ID? Let's see what happens. Yeah, now Anne is all the way at the back. That's great. Okay, so now we only have one more thing to do, which is, now that we've tested it, we need to rename this to this, and we need to remove this. In order to do that, we're going to import OS. Import OS. And the first thing we're going to do, okay, let's just comment this out. Format, comment out. Oh my goodness. The notes. Touchpad is not helping me. Format, comment. Okay. OS dot remove this file. Student records dot dat. And after removing that file, we want to rename. So we want to rename what we have now got temp.dat, and the new name should be studentrecords.dat. And let's test to see if it's working. You know, the better way to test it is to go over here and change this. Okay. And uncomment it. Right. Seems to be working. Okay, that's the last exercise. Let's quickly go to the checklist. And let's have a look. We've learned about reading binary, writing binary, and appending binary. The main thing we have to remember is import pickle, and we use pickle.dump to put a record to the file, and pickle.load to pull a record from the file. We also have to remember that we've got to load n times to get to the nth record. Here we have os.remove, quite an easy one, and os.rename, also quite an easy one. When it comes to opening the file and closing the file, it's the exact same thing as here. We just have a B, RB, WB, or AB. And that's all. So good luck on your exam. Happy studying. Don't forget to practice past papers. See ya.